With that, my main presentation tonight is all live code. So we'll have an identify PowerPoint. But since this is a higher level talk than, this is Gradle or this is Spock, I'm going to take a few minutes up front to kind of assess your level of knowledge and get you kind of acquainted with the general technologies we'll be using. So first, get to know where we stand. How many of you guys have at least heard of, kind of know what REST is? Pretty good. How many of you have actually coded something RESTful, whether it's on the client or the server side, even if it's like a toy thing? Okay, and how many of you have done something pretty serious, like actually set up a REST service somewhere? Okay, good. That's pretty good representation from the times I've given this talk before. Okay, so same three questions for Jersey/JAX-RS, which is the Java API for RESTful services. How many of you know about it? Use it a little bit? Use it a lot? Okay. And Spock? Know about it? That's impressive, actually. Use it a little bit and use it a lot. Okay. And then finally, Gradle. Everybody's got to know about Gradle by now, right? Okay. How many of you have actually used it for something? Played around with it, touched it, used it for projects at work or something kind of serious? Okay, cool. So we got a little spread of knowledge there. All right, so we'll fly through this kind of quick. For those of you who didn't put your hand up for REST, which I'm sure anybody didn't, so I'll go through this really quick. REST, at large, is all about resources, representations, identifiers. A resource is anything that can be given an identifier. That seems like kind of a recursive definition. But a resource is just like a conceptual thing. It can be abstract, it can be concrete, but it's a thing that you can identify. A representation is often mistaken for a resource, vice versa. A representation is not a resource, but it's a view of a resource. For instance, these are representations of a circle. Okay? 3 different representations. They all represent the same circle. So the circle is the resource. The abstract idea of the circle is the resource. The representations of that resource. Identifiers usually look like this in REST. Everybody with me so far? Small circle. This is the identifier for a specific circle. And then the third one there is the members of some circle, at which point we stop and ask ourselves what kind of circle are we talking about now. But I just need an example for a nested resource. So you've got a collection identifier for a specific member of that collection and a subcollection of that member. And then again, further down, you can identify a specific member of that specific circle. Okay, pretty simple, pretty straightforward. And of course, these look like URLs we've been using since, nice. But REST gives them a very specific meaning and distinction, which is that of an identifier, and a unique identifier of one specific thing, one specific resource, not a representation. These are identifiers for resources, not representations. That's an important distinction. Okay, so now you're all REST experts. We're good. Jersey. Jersey is the library of the will create a RESTful web service, and to access it, it'll be the client library to access the REST service. It's the reference implementation of JAX-RS, which is the official, like I said, the Java API for RESTful services. And in most of my code, I'll actually be dealing just with JAX-RS classes. Jersey is just the underlying library that powers all provides the implementation of the API. One exception, though, is the Jersey test framework, which is pretty cool. It's specific to Jersey, ships with Jersey, and it makes it really cool. It's really easy to test Jersey web services. Or really, I guess, yeah, it would have to be Jersey web services. Okay, so speaking of testing, Spock, of course, is the logical choice for writing expressive tests. I even grown. Come on. Yeah. It's built on top of JUnit. So it runs pretty much anywhere, and any tool that can run JUnit can run Spock tests. And it uses a Groovy DSL to make tests much more readable than pure Java ever could. It just takes testing to a whole new level when you've got Groovy together with this really nice DSL syntax from Spock. Finally, my build tool tonight, extending the Gradle Groovy usage tonight, will be Gradle. It's the new kid on the block for build tools, of course. Kind of combines Ant's flexibility with Maven's conventions. Throw in a little bit of Groovy for easy configuration, and you've got Gradle. kind of lets you do whatever you want without boxing you in, but giving you lots of stuff for free, kind of like Maven did, just without the Maven box. So that's my toolkit. We have Jersey to provide reference, Spock for tests, Gradle to build and run everything. Okay, so we're going to kind of go through those, not in that order. Maybe I should reorganize this in the right order. You guys are actually the first guys that have gotten this intro presentation. The other times I kind of winged it. At my jug, I didn't need it because we've already had presentations on all this stuff, but it's been evolving as I go. So that's why this feels a little bit rough. All right. Unless there are any questions. Done so far? Everybody good? Okay, let's get on with it. Now I'm going to sit. No more slides. Okay. So first, we need a project record.
Ryan, I'm sorry to interrupt you quick, but if you go back to WebEx, we're actually not seeing your slides or your screen right now. See that button, share my desktop?
Yes.
Perfect. Click that and share your desktop. Perfect.
Thank you.
Thank you very much. Sorry to interrupt.
Thank you, Bree. All right. Hopefully that works out. Okay. So, project director. That's where we start. Now we're going to build this thing with Gradle. And Gradle comes out of a build.gradle file. So here's our build script. We're going to be building a Java project. Say apply plugin Java. With that, for those of you who aren't familiar with Gradle, since not many of you have used it, that gives you what you would tend to expect from a Maven Java project. You've got main and test source and resource directories. It understands how to build and compile and create jars. It just knows, just with that one line right there. Now we're going to be testing with Spock, which is Groovy, so we'll also want some Groovy. Now, here's a tip for you. When you use Groovy plugin, you use Java for free. So that's all we really need. Also, to use Groovy, we have to tell it where to get Groovy from. And this is where I'm going to say, feel free to interrupt me at any time to point out typos, because I always misspell that when I'm talking. I think I got it right that time. But it goes much faster if you point out the typos before we have to go back and track it back and find out where it came from. So, in our dependencies, we'll say, I want Groovy and of course, if you're familiar with Maven, this is just a typical Maven coordinate compressed down out of that much XML to that much text. So that's our group. Now, it'd be nice to have some code coverage numbers to look at afterwards. Kind of a little bonus. Jacoco is, anybody familiar with Jacoco? That's something I should ask about. Okay, you guys know Covertura and or Emma? So those two projects, Covertura especially, and I think Emma, have been pretty much dead for a couple of years. There's no active development on them, and technically they do not work with JDK 1.7 or JDK 7. So for some reason, if you use Maven and Covertura, you can get it to work with Java 7 just fine. I don't know what it is, but Jacoco is the new. Jacoco is the new code coverage library that kind of emerged from Emma, and the guys that wrote Emma. So that's where you should probably be looking going forward if you're going to start moving into newer versions of Java. So there is a third-party plugin out there to add Jacoco coverage to Gradle, and to show you how simple it is to add the Gradle, to use Gradle plugin. It doesn't particularly have to be bundled up in any particular way or anything like that. Just go Gradle Jacoco, this guy right here, and you can see it's just a GitHub project that has a README and a Gradle script. So we've got a Gradle script, which is kind of like just what I'm writing. It's just Groovy. It's a Gradle script. But if you get a link to the raw text version of this guy, you copy that URL. I can say now I get that plugin. The reason I had to do build script here is because that particular plugin / script expects to be hooked into the basic mechanics of Gradle itself rather than apply to tasks on your particular project. So this needed to kind of go one level abstraction down to hook into the mechanics of Gradle to do all the instrumentation and edit agent and everything. But for a typical plugin, if I knew a location of the GUI plugin, I could just stick a URL right in there and it just pulls it up from wherever it was. Pretty cool.